Struggling with math? You're in the right place. Welcome to Explaining Mathematics, the channel where we simplify tough problems, break down complex formulas, and turn confusion into clarity. From basics to advanced topics, we explain it all step by step. Let's start solving.
All right, today we're going to pull back the curtain on the hidden math behind, well, explosive growth. We're talking about those powerful little functions that are the secret sauce behind everything from viral videos blowing up overnight to how your retirement savings, hopefully, grow over time. Let's just dive right in. It's a pretty simple question, right? But the answer is fascinating. Whether we're talking about a population boom, how fast information spreads, or an investment that just keeps compounding, there's a very specific mathematical engine that's driving all that rapid change. So you gotta ask, how does it actually work?
So here's our game plan. We're gonna start with the basic language of growth. Then we'll meet the engine that actually powers it all. After that, we'll figure out how to work it in reverse, see where it's hiding out in the real world, and finally, hopefully, you'll walk away with a whole new way of looking at the world around you.
Okay, first things first. We need to get on the same page and understand the language here. Because when we talk about this kind of explosive growth, we're not talking about simple 1 plus 1 plus 1 addition. Nope, it's something way more dramatic. The key idea here, the absolute game changer, is multiplication. See, instead of just adding a fixed amount each step, we're multiplying by a fixed amount. It's the difference between walking up a flight of stairs, step by steady step, and launching in a rocket. One is a steady linear climb, sure, but the other, that's an accelerating, absolutely explosive launch. So let's pop the hood and take a look at the engine itself, the exponential function. This little thing is the core mechanism that powers all of that incredible multiplicative growth. It looks pretty simple, doesn't it? F of x equals a to the x. Here a is our base. That's the number we're multiplying by over and over. But x, the variable sitting up there in the exponent, that's the real star of the show. It tells us just how many times we need to multiply that base by itself. And this table just illustrates it perfectly. Take a look at the function f of x equals 2 to the x. When x is 1, you get 2. When x is 2, you get 4. If x were 3, we'd get 8. You see what's happening? It's not just getting bigger, it's doubling at every single step. That, right there, is the awesome power of the exponent. But here's the cool thing. This engine actually works both ways. When that base number is bigger than 1, you get that rocket ship growth we've been talking about. But if it's a fraction, something between 0 and 1, you get exponential decay. Think of a radioactive element losing half its mass over time. It's the same engine, just running in a different direction. All right, so we've got this incredibly powerful engine. But what happens when you already have the result and you need to figure out what powered it? What if we need to work backwards? Well, for that, we're going to need a key to unlock the exponent. Let's make this real with a problem. We know that 2 raised to some power x equals 8. Now, we could probably just guess. Let's see, 2 times 2 is 4, times 2 again is 8. Okay, so x has to be 3. Easy enough. But what if the numbers weren't so nice and clean? We need a real tool for this. And here it is. This is our key, the logarithm. Its one and only job is to solve for that exponent. It basically asks the question, hey, to get this final number, what power did I need to raise my base to? Okay, now look at this table, because this really spells it out. Exponential form and logarithmic form, they aren't two different ideas, not at all. They're literally just two sides of the exact same coin. Saying 2 to the power of 3 is 8 is the exact same thing as saying the log base 2 of 8 is 3. You see? The first way focuses on the result of the growth, while the second way focuses on finding the power that drove it. This might just be the simplest way to think about it. Logarithms just undo exponents. That's it. It's just like how division undoes multiplication. They're perfect partners in crime. All right, now let's get to the fun part and see where this math actually shows up in the real world. Because I promise you, this isn't just some abstract theory. This is the actual blueprint for how so much of our world really works. Let's talk about compound interest. The whole secret is that the interest you earn starts earning its own interest. That's that multiplicative effect we keep talking about right there in action. $1,000 at 5% becomes over $1,150 in just 3 years, all thanks to that exponential power. And seriously, it is everywhere. Modeling population growth, tracking radioactive decay, the Richter scale for earthquakes, the decibel scale for sound, even things like the efficiency of computer algorithms and how your car depreciates in value. All of it, every single one, is built on this foundation of exponents and logarithms. So, after all that, what's the big picture here? What's the main takeaway? How does this give us a whole new lens to see growth? It really boils down to this core relationship. Step 1, exponential functions, they describe the rapid growth itself. Step 2, logarithmic functions, they let us work backward and figure out the power that caused it all. And step 3, together they form this complete toolkit that lets us understand and even predict some of the most dynamic changes in the world. So, I'll leave you with this thought. Now that you can kind of recognize the pattern, this signature of exponential growth, what else in your world is secretly running on this powerful mathematical engine? Just look around you. From technology to nature to your own finances, you might be really surprised by what you find.
If this video helped you understand the topic better, don't forget to like, subscribe, and turn on notifications so you never miss a lesson. Comment below what topic you want explained next. Thank you for watching Explaining Mathematics. See you in the next problem.